Hello, hello. Man, long time no see. Welcome back, me, and I guess you guys too if you're watching. As you know, I took a little break, or maybe you didn't know, but it was the end of the school year. Obviously things are hectic, and I didn't have time to stream. But I'm back. And as finally promised, I'm going over this year's AASL Paper 1 from Time Zone 2. Hey Nalani. Shoutouts to Hayu, my Australian student who snagged me a copy of this. But yeah, I don't think this will take too long because it's a Paper 1. And then I guess I'll pass my judgment on it and see whether or not it was actually like fair for the given circumstances of this year. Anyways, let's get into it. We got circle. It has radius r. Sure, okay, this is 1 radian. The perimeter of the shaded region is 12. So this thing is 12. Find the value of r. Okay. So the perimeter is this thing, plus this thing, plus this thing. And I know that both of these are radii. So currently, the perimeter, which is 12, is made up of 2 radii plus the arc length. And the arc length is a pretty straightforward formula. It's just theta times r. And we know that theta is 1. So this is plus r. So 2r plus 1r is 3r, which means that the radius has to be 4, because 3 times 4 is 12. Then we can find the area of the non-shaded region. Okay, there's lots of ways to do this, but you will need to use this formula eventually. The arc sector formula, which is 1/2 pi, or not pi, is it pi? I think it's theta. Delete. Theta r squared. So this is the area of a sector, and there's lots of ways you can do this. You can either find the other side of this angle and then use the formula to find this part. You can find the area of a circle and then subtract this part. It doesn't really matter. I'm going to do it the other way. So this thing is 2 pi minus 1, because 2 pi is a full circle, and then I'm just subtracting this angle, which is 1. And then this is the angle I can put in to here for theta. And I think we found out the radius was 4, right? Okay, and then let's simplify. 4 squared is 16, divided by 2 is 8, so all of this is going to be 8, and then 8 multiplies into here. So the exact value of the non-shaded region should be 16 pi minus 8, or something like that. Easy peasy. Okay, then let's see the next question. Oh, this one's kind of weird, but it's not that bad if you know what to do. Paste. Okay, so consider 2 consecutive positive integers, so n, and then the next number, which would be n plus 1. Show that the difference of their squares is equal to the sum of the 2 integers. So show that the difference of their squares, so in other words, if I take the larger one and then I square it, and then I subtract the smaller number and square it, this should be equal to the sum of the 2 integers. So this needs to be equal to n plus 1. And then this is just a proof, right? We just simplify both, like mostly the left side, and then if they're the same, then they're the same. So n plus n is 2n. And then over here, expand it out, you'll probably find out that it's the same, right? Because this is n squared plus 2n plus 1 minus n squared, and then the n squareds cancel out. And then there you go, left side equals right side. We've proven it, easy peasy. Okay, number 3. Looks like some trig equations with identities. Show that this equation can be written in this form. Okay, so this is pretty straightforward. We have cosine squared, and then we want it in terms of all sine, so we can use the Pythagoras identity. So 2, and then cosine squared we can write as 1 minus sine squared. And then plus 5 sine x equals 4. Okay, simplify everything, collect it to one side because we need one of the sides to be 0, and it should equal this, right? Okay, let's see. 2 minus 2 sine squared x plus 5 sine x equals 4, and then I'll move everything over to the right side and then switch the position of this because I don't know, most people prefer their zeros on the right side. Okay, so then we have, this is going to be positive 2 sine squared x. We'll have negative or minus 5 sine x. And then when we move this over to the right side, it becomes 4 minus 2, which is 2, and then, so this should be plus 2. Anyways, you just need to show this. Easy peasy. Hence, solve this equation for 0 to 2 pi. So now we solve it. This is a quadratic trigonometric equation, so we factor it. And then we just need to find out what goes in each factor. This is negative, so I think these are both subtractions. And then these two terms need to multiply to make 2, so one of them has to be 1, the other one has to be 2, and then you just have to find out which one goes where. This one needs to be 2, because you do need to have minus 5 in the middle, so then 2 times 2 is 4, and then you have this 1 times a 1, and then you add them together, so that makes 5. Okay, and then this basically implies that sine x needs to be equal to 2, and then this has no solution because sine of x can't be bigger than 1. And then over here we have essentially sine x needs to be equal to 1/2. Okay, and then we should have two solutions from that. Uh-oh. Summertime. A, S, T, C. We should have one solution here in quadrant 2 and one solution here in quadrant 1. This is a special ratio though. And then I think that is a reference angle. Gosh, this is what I mean by summer. I've forgotten everything already. 2, 1. Because this is the opposite and then this is the hypotenuse. I think this is pi over 6, right? Okay, so we have two answers for x. In quadrant 1 we have pi over 6, and then in quadrant 2 we have 5 pi over 6. Still not too bad. This is a very standard like trig. They made it even easier for you. They broke it down into two parts. Normally they would just ask you to solve this. Like they would just ask you part B. So it's still fairly easy. Okay, copy. So on to question 4. Ooh, binomial expansion. So we have x plus k to the power 7, and then the coefficient of the term x to the power 5 is 63. Find the possible values of k. Okay. I don't have the formula book on me because I can't find it online. Actually, wait, no, I did find it online. So the general term for any expansion is in your formula book. This is first edition, which has some incorrect equations, but that's fine. So it's a little hard to see, but it's right here. So NCR A n to the power, or to the power of n minus r times b to the power of r. So using the numbers and variables we have NCR, so 7 CR. We don't know what r is. And then the first term in the binomial, which is x, and then this is to the power of 7 minus r, and then times k to the power of r. Now, we need to find out what r is, but that's easy enough because if we consider the x to the power of 5 term, this needs to be equal to 63x to the power of 5. So, you know, since this is the only place where x is gonna get powers from, like this is the only factor that has x, then 7 minus r needs to be 5. In other words, r needs to be 2. So what does that mean? That means that 7c2 times k to the power of r needs to be equal to 63. Oops, and then r is 2. 2. Okay, and then we need to calculate 7c2. This is a non-calculator question, so you can either use the formula, which is right here, or you can literally just make like an 8-layer Pascal's triangle. That seems more fun. I'll do it that way. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Hold on. This is 1, 2, 3, 4, 5. Okay, 2 more layers. One, 6, 15, 20, 15, 6, 1, 1, 7, 21. I would honestly not do it this way during an actual exam. But like I said, this is more fun. I'll do it the other way too, just so that I don't have people bugging me about it. Okay. How does this work again? So 7c2 implies the 8th row because the numbers start at 0, and then 2 represents, I think it represents either the 3rd or the 2nd. Uh-oh, I should know this. It represents the 3rd. Let's go with the 3rd. I'll double check it doing it the other way. So again, 7 and 2. And then remember, the Pascal's triangle starts at zeros. Index is a 0. So this is the 0th, and then this one is the 0th. Okay, anyways, 7c2 is 21. So 21 times k squared equals 63. So k squared is equal to 63 divided by 21, which is, I think, 3. So k has 2 possible values, plus or minus the square root of 3. Okay, if you want to use the formula way to calculate this, then this is 7 factorial divided by 2 factorial divided by 7 minus 2, which is 5 factorial. And then Factorials are just like descending multiplication. So this is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then these are the same thing. So what that means is 5 factorial can cancel out with most of the factors in 7 factorial. The only ones that are left are 5 times 6. And then we have, well, 7 times 6 divided by 2 times 1. So 7 times 6 divided by 2 is 21. Yeah, and then from there, you put it in, and then you do the same thing. Anyways, again, very standard question. Very straightforward. Damn, paper 2, or time zone 2, you guys seem to get it a little easy right now. But then again, that was only question 4. Okay, next one. Consider a function defined by this for that. Okay. Diagram shows part of f which crosses the x-axis. Okay. L is line to tangent at some other point. Okay. Find the exact value of a. Okay. So a is the x-intercept. In other words, my function needs to be equal to 0 here. So the natural log of x squared minus 16 needs to be equal to 0 here. And then we can solve for x pretty easily. We change this into an exponential expression. So this is e to the power 0 is x squared minus 16. And then did we do paper 1 or 2 tests in class this year? What? We did both. E to the power of 0 is 1. Which means x squared is 17. Which means that x is the positive root of 17. Don't need to consider the negative because of, well, the domain. Okay, so there's a. And then given the gradient of L, okay, is 1/3, find the x coordinate of B. So we want to find this x coordinate, and we know that this gradient of this line is 1/3. And we can calculate this gradient because that's going to be the derivative of the function at this specific x coordinate. So we take the derivative. So f prime of x is going to be 1 over x squared minus 16, and then chain rule times 2x. Okay, and then we know that this needs to be equal to 1/3 at a specific x value. Okay, and then we can just solve this equation for x. Let me just write this in a more efficient way. Okay, lots of ways you can solve this. You can do like a cross multiplication thing. So you'll end up with 6x on the left side is equal to x squared minus 16. We have a quadratic. We can solve the quadratic. At least I hope we can. Is this factorable? 16 is 4 times 4, right? And 2 times 8. Okay, we can do 2 times 8. Lucky. So x minus 8, x plus 2. So our answer is that x value has to be positive 8. And not this one, because that's negative 2. Oh, not bad. Another pretty straightforward one. Okay. Moving on. They should start to get harder now, because I'm on question 6. Okay, we got diagram, we got triangle. Given that cosine of the angle C is 3 over 4, find the area of the triangle. Okay, so area of a triangle, if you have a side, an angle, and a side, give your answer in the form PQ blah blah blah. Okay. Oh, but then we don't know what x is, right? Okay, we gotta find out what x is first before we find out the area. And that's fine. We can use cosine rule because they tell us cosine c. So then I'm gonna use cosine rule for little c. So what that means is that I have 10 squared is equal to 2x squared plus x squared minus 2 times 2x times x times cosine c. Anyways, and then I'm doing this because, again, I already know what cosine c is. They told me. And then we'll just go from here and see what happens. So I got 100. On this side, I have 4. This is 4x squared plus an x squared. Makes 5x squared. Minus 4. Oh yeah, and then this is 3 over 4, right? Oh, okay, things are gonna work out, I think. Okay, so cosine c is 3 over 4, so I can just replace cosine c with 3 over 4. And then this works out nicely because what happens is 2 times 2 is 4, which cancels out with that 4. And then I'll end up with 3x squared. Okay, so 100 is equal to 2x squared, which means that x squared is 50. So that means that x is root 50. And then they want a simplified radical, so I guess I'll simplify this. So this is 5 root 2. Because 50 is 25 times 2, and then we square root the 25, and that gives you 5. And you can't square root the 2, so it stays as a root 2. Okay, we have x. Excellent. And then now we can calculate the area of the triangle. So first off, let's write that in. So x is no longer x. This is 5 root 2. And this is 2 times 5 root 2, which is 10 root 2. Okay, and then we're almost there. There's one more tricky thing you need to do. But okay, here we go. The area is 1/2 times 10 root 2 times 5 root 2 times sine c. Right? If I have an angle in between two sides of a triangle, I can use the 1/2 a times b times sine c formula in your formula book. And then here's the tricky part. We don't know what sine c is, sort of, but we do know what cosine c is. Cosine c is 3 over 4. So you can kind of clearly tell that this is in quadrant 1 because this is an acute angle. So what we can do is we can build a triangle. So here's your angle C, and it says that the adjacent side is 3 and the hypotenuse side is 4. We can use Pythagoras to find out the opposite side. 16 minus 9 is 7, so this is square root 7. So that means that sine C is opposite over hypotenuse, so root 7 over 4. Nice, okay. And then we have so 10 divided by 2 is 5, and then 5 times the other 5 is 25, and then root 2 times 2, well, root 2 times root 2 is 2, so 5 times 5 is 25 times 2 is 50, so all of that becomes 50, and then 50 and 4 will reduce to 25 and 2. So your final answer in the format that they want is 25 root 7 over 2. Like this. Yeah, okay, that one was a little trickier. Are we on to the big questions yet? We are, okay. Okay, what's up? Cumulative, whatever. What is this? Number of hours students do something, whatever. Okay, we got 80 people, but you can see that at the top of the graph. Okay. Oh, and then questions are on the next page, I guess. Open. Okay, copy. Okay, question 8. Find the median number of hours per week that students spend doing homework. There's 80 people, so the median's gonna be at 40. So we can just kind of, here's 40. And then we follow the graph, and then boop, and then go down. So easy peasy, 14 hours a week. Not my students. Okay, given that 10% of these year 12 students spend more than K hours per week doing the homework, find the value of K. So there's 80 people, so 10% is 8. And we're looking for the upper 10%, because these are the people who spend more than a certain amount. So what we need to do is we need to go to 72. 72 is right here, the first square after 70, because there's 5 squares between 70 and 8, so each square is worth 2. So follow the line. Why do you hate these questions? They're so easy. So that goes right there. So then we follow that line going down. And there we go. 18. So the top 10% of students spend 18 or more hours doing homework. So K is 18 hours. And then here is the same information on a table. Okay. Find the value of P and Q. Okay, so there's lots of ways that we can do this. What's the best way to do this? Why do they have to do odd numbers? I don't like this. This is a different type of PQ question. This isn't like an expected value one. Okay, so let's find out the amount of people that are in 7 to 15. Okay, we know that there's 4 people from 2 to 7. So there should be 4 people. Yeah, you can see it right here. 2 squares up at 7. Okay, and then let's go to 15. So 15 is right in the middle. But luckily, that I think lines up very, very perfectly right here. And that's 11. So wait, what am I doing? Okay, 7 to 15. Am I doing this backwards? Oops, I'm doing this backwards. Okay, ignore what I just said. Okay, 7 people, or at 7 hours, we have 4 people spending less than 7 hours. And then I need to find out 15 hours. So I found 15 people. I want 15 hours, which is right here. Actually, that's a different question. Let's use a different color. Red. So 4, 15's right here. So this goes up. And I think that goes up to right here. And that means 60 people, right? Okay, so 4 to 60, not including 4, so like 56. The difference between the two numbers, 56. Okay, and then you can do the exact same thing for 21 and 24, but remember, you also know that there's 80 people, so all of these numbers together need to be 80. So 4 plus 56 is 60, plus 16 is 76, so Q needs to be 4. Okay, now there are 320 students in the school. So let's estimate the number of students that spend more than 15 hours each week doing homework. So if you look at the table, these are the students that spend more than 15 hours. So that's 16 plus 4, which is 20. Now, in terms of probability then, that's 20 out of 80 people. So the probability of spending, I don't know, and let's say X is the homework hours, spending more than 15, that's 20 out of 80. In other words, that's 1 out of 4. Okay, and then estimate the number of students that would spend more than this amount. There's 320. Probability of spending more than 15 hours studying is 1/4. So you just multiply the two together. 320 divided by 4. Which is what, 80? So there's about 80 people that spend more than 15 hours each week doing homework. Okay, now explain why the sampling method might not provide an accurate representation of the amount of time all students spend doing homework. Okay, this should be a free mark. You just need to explain why this might not be right. Okay, so I don't know. Maybe you only surveyed the dumb kids. Whatever, just make up something, right? How can you extrapolate 80 students to 320? maybe you surveyed the IB students, and then the rest of the school isn't necessarily IB. Or like I said, maybe these 80 students are really dumb, and they're spending way too much time doing homework compared to the rest of the school. And then suggest a more appropriate sampling method. I don't know. Oh wait, I think they're looking for a specific answer for this. I think maybe. Are they? No, they're not. Oh, whoops, all the students. Okay, never mind. I thought they would let you have some fun. Sorry, this is about year 12. You can't expand that out to all of the students in the school, because not all the students are in year 12. Fine. I wish I could have said this answer instead. Okay, not all students in school are year 12. Boring. Okay. It's just a more appropriate sampling method. Survey other grades. Or survey all grades. All years, whatever you want to call it. Okay, easy 2 marks. Is that the question though? Is that the end of the question? That was also an easy question. Overall. Man, okay. I'm disappointed that I couldn't say my answer. Copy, paste. Very unusual question, I'm not gonna lie. They don't often ask like statistics, like the validity of statistics in their questions. But whatever, that should be a free 2 marks. Okay, we have a function, here it is. Graph touches here and here as shown. Okay, the shaded region is enclosed in this graph right here between points A and B. Find the coordinates of A and B. Okay, so if you look at this equation, the period of this function is 2 pi. And you can see it's graphed from 0 to 4 pi, and then there's very clearly 2 cosine waves, because this is a cosine equation. The lowest point in a cosine graph with a period of 2 pi is at pi. Every pi. Well, every other pi. So at pi, and then at 3 pi. Because a normal cosine graph looks like this, right? And then right here is pi. So there's A and B. Then we need to show that the shaded region is 12. Okay, so we're going to take an integral from pi to 3 pi of this. So I guess I'll do it right here. Okay, and then this should be easy enough to do. Take the integral, you get 6x plus 6 sine x, plug in 3 pi, plug in pi. Okay, and then you're gonna have 6 times 3 pi. I'll just plug it all in. Plus 6 times sine 3 pi. Minus 6 pi minus 6 sine pi. Okay. And then every multiple of pi, sine is 0. So these are all 0. Don't worry about them. So what do we have? We have 6 times 3, which is 18. 18 pi minus 6 pi. So that is equal to 12 pi. Easy peasy. And then let's see. The right cone in the following diagram has a total surface area of 12 pi, equal to the shaded area in the previous diagram. This has nothing to do with the previous diagram, but okay, throw in a cone question. Cone has a radius of 2 and a height of h and a slant height of L. Find the value of the slant height. Okay. Shoot. What's the surface area of a cone? It's in here. There's no way that they can expect you to know what the surface area of a cone is. Okay, I think they updated it to have more shapes because it's not on here. Yeah, I'm gonna assume that they're gonna give you the surface area of a cone volume because this is the first version, and I'm fairly sure they added more stuff. So let's see, surface area of a cone. Okay. So the actual like cone part is pi times r times L, and then if you have a circle on the bottom, then you add obviously the area of the circle. So we know that the area is 12 pi. This should be equal to pi times the radius times the slant height plus pi r squared. Oh, and then r is 2, right? Okay. Why did they give you the variable h if you're not going to use it? Now I'm wondering whether or not they give you this formula. I feel like they should though. Okay, let's Google this. IB Math AA Formula Book 1.1. 1.1. They don't give you the volume of a cone? Oh, it's in the later section. Curved area. Oh, it's right here. Okay. Okay, I went on a little rant for nothing. My bad. Okay, here you go. So we can solve for L, right? Pretty easily. So this needs to be equal to 12 pi. I have 2 pi L plus 4 pi. This thing then needs to be 8 pi because 8 plus 4 is 12. And then that means that L needs to be 4 because 4 times 2 is 8. Of course you can just do algebra and solve for L, but it's the same thing. Okay, hence find the volume of the cone. Ah, okay. This is where the H comes in. This is 4. Volume of a cone is 1/3 pi r squared times h. And we need to find h, but that's easy. They very clearly kind of told you that you need to use Pythagoras because you have this right triangle with the height, the slant height, and the radius. Okay, so 16 minus 4 is 12, so h is root 2, or sorry, root 12. That's root 12. And then we can just put it in. 1/3 pi r squared times h. So 4 root 12 over 3 pi. And then you should probably simplify this radical. Okay, I'll do that before I combine it all together. So 12 is 4 times 3. So this is 2 root 3. Okay, so then that means that we have 4 times 2, which is 8. There you go, something like this. Here's your volume. Okay. Odd question, but okay. And then final question. Ooh, physics question. Okay, a particle A travels in a straight line. Okay, and then here's its displacement. Sure, okay. From 0 to 10, shown in the diagram, and then particle A starts at the origin, passes through the origin again here. Find out where this is. Okay, so that's easy enough to do. Here's 8t minus t, so here's our function, t squared, and then find out when is equal to 0. So you can kind of clearly see it, but let's just factor this out. So either this function will be equal to 0 at 0, because then this is 0, or when t is 8, over here. So this is 8. So p equals 8. And then particle A changes direction when t equals q. Find the value of q. So you can see it's going up, or left, or I mean right, and then it goes left or down. So it changes direction here. And we need to find out where this is. Because it's a parabola, it's at the vertex. And because of symmetry of a parabola, this has to happen between 0 and 8, which is 4. Okay, so that's at 2. Then find the displacement of the particle from the origin when t equals q. Okay, so basically they're saying plug in 4 into the function and then calculate the displacement. So s at 4 is equal to 8 times 4 minus 4 squared. 8 times 4 is what, 32? 4 squared 16, 32 minus 16 is 16. So the displacement is at 16. Okay, so there you go. Displacement 16. Then find the distance of the particle A from the origin when t is 10. Okay. Why is this a question? Whatever. Okay. So what we're going to do is we're going to plug in 10. Same thing. So 80 minus 100, negative 20. And then I guess this is why they're asking this, to test if you know the difference between displacement and distance. Displacement has a direction, so the displacement at 10 seconds is negative 20. The distance is just the absolute value of this. So the distance is 20. 20 meters. Okay, the total distance traveled by particle A is given by d. Find the value of d. Total distance, okay. Oh, but this is only 2 marks. So is there a tricky way to do this? Oh, okay, easy peasy, I got this. so here's at 10, right? And then we know that they travel 20. Okay, a lot of people might use calculus, but look at the mark distribution. There's only 2. If you wanted to do calculus, you would need to integrate from 0 to 8, and then from 8 to 10. But just look at this. This particle moves 16 meters upward, let's say. Then it moves 16 meters downward. And then it continues to move 20 more meters downward. So its total distance is 16 plus 16 plus 20, which is 52. Okay, then a second particle travels along a straight line. Here's its velocity, linear velocity. And then when t is k, the distance traveled by particle B is the same as the other one. Okay, find the value of k. Okay. It's only 4 marks, so it shouldn't be that complicated. I just want to go through my options before I decide what I want to do. Okay, so let's see. Okay, so I decided to graph the velocity. And because it's a linear graph, it's very straightforward. It starts at a t value, or a value of 14 when the time is 0. And then it will go all the way to 7 here. Right? And then it might continue on afterwards, because we don't know how long this particle moves for. Okay. I'm assuming it moves for more than 7 seconds. And then I know that the area of these 2 triangles is going to be the distance this particle travels, which is 52. And so triangles, again, you don't need to use calculus to figure this out, because you have basic geometric formulas. This triangle has a height of 14 and a base of 7. And then if you divide that by 2, so 14 times 7 divided by 2 is 7 times 7, which is 49. Again, area of this, 1/2 14 times 7. Base times height divided by 2. And then this is nice, because this is an area of 49, and we need to know that the total area is 52. So this area needs to be 3. Okay. Now, how do we calculate this area? So I know that this is 1/2 the base. So the base is the distance from k to 7. So that's right here. And then we also need to know the height. But the height is the y value. The height is just the y value of the function when it's equal to k. In other words, we plug in k here. So 14 minus 2 times k. Right, I just plug in k here. This will give me the y value. Oh, well, technically this is negative. So we want the positive version of this. So I'm just going to stick a negative in front. Because, again, this y value, 14 minus 2k, needs to be negative. And then I am doing geometric calculations, so I turn it positive by multiplying it by negative. Anyways, this is equal to 3. So solve for k. Okay, what can I do? First, I'm gonna multiply the 2 over here. Don't want to deal with fractions. Gonna also multiply this negative into here, this factor, so that I have k minus 7 times 2k minus 14. So that will just, you know, switch these two. Then expand out, collect like terms, make it equal to 0, probably factor it again, and then I'll have different values for k. So we have 2k squared. Please let this be easier than it looks. Nope. Minus 28k plus 98 equals 6. I can think of better ways that I could have approached this, but it's fine. Okay, assuming I multiplied this right. Let's see, 7 times 2 is 14, and then 14 is 28. 7 times 14 is 98, right? 7 times 4 is 28. 28 plus 70 is 98. Yeah, okay, seems good. Okay, collect everything on one side. And before we factor, we can divide everything by 2 because we have a bunch of even coefficients. So what is this, 46? Okay, and then probably factor this. One is plus, one is... Actually, they're both minus. $46. Okay. 2 times 23. That's it, right? Okay, let me double check my work here. Here's V, right? 14 minus 2t. So, yeah. 7 times 7 is 49, so that's fine. Assuming that I did this right, which I should, up 16, down 16, and then down 20. 32, right? Plus 20 is 52. So 52, 49, this needs to be 3, 3, k minus 7, negative 1/2, 14 minus 2k, is this not factorable? Did I do something wrong? Okay, let me try it the other way. It's a very, very similar approach, but maybe, I don't know, my algebra is messed up. It's summer. Okay, so what I'm going to do is same thing, except I multiply the whole 1/2 in. Because then I'll have k minus 7, and then k minus 7 equals 3. Oh, okay. It wasn't going to be a nice number, so I would have. So what you could have done if you did that way is quadratic formula. If you do it this way, then you can just solve it algebraically. So k is going to be 7 plus or minus the square root of 3. Okay, and then which one should we choose? Well, obviously we choose 7 plus square root 3. Because if we minus square root 3, it would be on the other side, which doesn't make sense. It needs to be on the right side, so you need to add them together. Okay, And then I think that's the last question. Okay, cool. So, time for my assessment. I honestly think this is easier than times on 1. I had no issues with any of these questions. Some were, again, slightly weird, but not... I think this was overall easier than times on 1. Obviously, the final question is the hardest one. And you can get into some decent trouble if you start doing these using calculus, which they kind of bait you into because, you know, usually total distance and stuff is calculus, but it doesn't need to be, as you've seen here with the geometry bit. But yeah, given you only have one really hard question, and my memory of times on 1s, I'm gonna say times on 2s was easier. But yeah, not saying that times on 1s was super difficult, but I would say it is more difficult than this. This is all very standard. Yeah. Okay, I'm gonna end it here. Just finished under an hour, so that's pretty good. I don't think I have any major mistakes, but I'm sure someone on YouTube will comment if I did. But yeah, okay. Good to be back. Hayu also sent me paper 2 for SL. I still don't have any HL, but I don't know how often I'm gonna stream. It's the summertime. Maybe I'll only do once a week, so maybe you'll see me again on Sunday. Might be busy Tuesday, Thursday anyways. But thank you for tuning in and watching. See you guys later. Goodbye.